I meant to set up problem number 50. Problem number 50 came from that compound interest project. So you probably are okay with that one, but let me go ahead and plug in everything in. So 15,000 was the amount accumulated, goes in for A. 10,500 was the amount invested. That's your principal. That's your P. The interest rate was 6.75. So you move the decimal 2 places to get the decimal form of that. Okay, and that right there in my formula, that's the R is there on top. It almost looked like an N, but that's your R. These are the N is down here. It's going to be, the interest is going to be calculated 4 times a year. So that N goes in 2 spots, and then we don't know our T. That's what we're actually trying to solve for. Okay, so I might come in on this one and work on getting rid of the 10,500, maybe cleaning up that part right there. So let me divide by that 10,500. Okay, and kind of see what that turns out to be. Now, if you are going to go ahead and do the division, let me see what it turns out to be. You get a decimal. If you're going to do that, don't round off very much because you don't want to introduce error, but it'd be okay if you did that. You just want to keep some accuracy. So, keep a good number of decimal places. Okay. And then here, let's clean this up. So this is going to be 1 point. And then let me take the 0.0675 and divide by 4. Okay. So that's 1.016875 raised to the 4t power. Okay. Now the t is what we're solving for. So let's put that on the left. Okay. And then let me put the 1.42857, and there's no set number of decimal places. I'm just saying if you're going to not leave it as 15,000 over 10,500, you don't want to introduce round off error. So keep a lot of decimal points. Now you can come in and do any kind of log on both sides. So I might do just log on both sides, or maybe ln on both sides. It doesn't matter, since this base doesn't have one of the buttons on my calculator. There's no advantage to using a particular log. But if I use ln on the left, I got to use ln on the right. Same thing on both sides. Okay. All right, so that means this can be brought down in front now. That's the third property of logarithms that tells you can do that. Okay, so that's where we're at. And ln of a number, that's just a number. So we're working on getting this t guy by himself. So since there's times all the way around, we'll divide by all of that on both sides. Right, you need to practice entering that on your calculator, because this needs to be grouped when you do that. After your division sign, you need to have both 4 and the ln of all that in parentheses, or it's not going to be correct. You have to make sure they're both getting divided. All right, and then when you practice doing that and get it, you should get around 5.3285, something like that. Okay. We're going to round to the nearest tenth. So it'll be in about 5.3 years. Okay. Actually, I did more on that than I meant to. That's okay. All right. What I really wanted to do is do this video is going to be on the logarithmic equations. Okay. So that first problem kind of went with the last video. I just neglected to do it. Now I wanted to look at some of these the problems that start out with a log in them. These are a little easier in my opinion. Okay, when you write that, these should all be on the same line. Okay. All right, so these are a little easier because to undo the log base 2, I'm just going to do 2 to the left side and 2 to the right side. And the 2 and the log base 2 cancel out. And we get x plus 3 equals 2 to the third, which would be 8. Take away 3, and we wind up with x being 5. And you do need to check these. Check these. Check all log equations. Okay. Right? You can't do the log of 0, and you can't do the log of a negative. But when you plug a 5 in, that gives you a positive 8, so that should be okay. This was number 45. Okay. All right, because I know this was hard to try to learn just based on my videos, I want to set up at least several of these. So 46 had log base 12. Okay. So this is one where you had logs in multiple spots. So it works good to condense this. You need to condense this into log base 12 of one thing. In addition, since logs are really exponents, that adding right there means that you could put this together using multiplication. So x times the 11x minus 1. Okay. So we condensed it to where it's one log. You could simplify this at this point if you wanted inside here. Okay. And now you got it kind of looking at number 45. So you'll do 12 to the left side, 12 to the right side. Okay. And that's going to wind up then undoing log base 12. So you'll have just 11x squared minus 11x. But over here, you don't have a 1, you have a 12. Okay. Bring the 12 over because this is quadratic. And then you kind of know where to go from here. Either factor. I think factoring is going to work if I can get it. Maybe like that. Yeah. Factor, get what each factor is equal to, and then remember to check. Okay. All right, so that's kind of the setup on that one. All right, now look at 47, and let's get it set up. Base 2 of x plus 3, log base 2 of x minus 4. Okay. This one had a minus sign. So when you condense that one, the x plus 3 is going to be divided by the x minus 4. Okay. Now you do whatever the base is. To undo it, you do 2 to the left side, 2 to the right side. The log base 2 and the exponential base 2 undo each other. So you have x plus 3 over x minus 4 equals 8. All right, so now just go in and multiply by x minus 4 on both sides. So x plus 3 equals 8x minus 32. Keep going. It's a linear equation and see what your x is going to turn out to be. But remember to check it because sometimes you can have no solution. So it could happen. Okay. So on this one, they asked like a two-step equation. It said, what's the setup, basically, and then what's your final answer? So the first blank, the answer would be x plus 3 over x minus 4 equals 8. It's the first blank, but that's not an answer to the question. That's just what the equation would look like if you wrote it without logarithms. And then the answer to the question is what you get after you solve all of that. Okay, so when you do that, you wind up getting x equaling 5. Okay, and so then one blank is the setup and one blank is the solution. Okay, and that happens on a couple of them. All right, let's try another one. 48. 48 has natural log, has logs in multiple places. You shouldn't bring the 3 over. That's just what photomath, I bet, does. Okay, you don't need to do that. You condense your logs. And since it was plus, you turn it into multiplication. But see, this one doesn't have just a number. It has the ln on it. So if ln of this equals ln of that, these insides have to be equal. And that's because I could do e to the left side and e to the right side to undo a natural log. So I'm left with x times x minus 2 equals 3. Okay. And so then I wind up going through the process. It's a quadratic. I get my possible factors. I kind of check it and it works. So I get 2 possible answers. And then I go back up here and I say, well, 3 seems to be okay because it doesn't give me a 0 or a negative. But if I plug in a -1 right away, I know that guy's out. So the only answer on 48 should be 3. Okay. All right, so let me stop sharing that.